Okay, so the next question you had was 20, and you actually left this one blank. The integral from 0 to 1 of 5x plus 8 over x squared plus 3x plus 2.
Mm-hmm.
Okay. What's going on here?
Well, this is, I believe, something that is solved by techniques of integration that I don't yet know.
That's right, yeah, we've skipped techniques of integration. And we're planning to do that in March. And this is a problem involving something called partial fractions. So partial fractions, say you break down 5x plus 8 over x squared plus 3x plus 2 into how the bottom factors. So how does the bottom factor here?
It's x plus 2 times x plus 1.
That's right, so we're going to look for a constant over x plus 2 plus another constant over x plus 1.
Okay.
So when we combine these, we're going to get the x's combined to be a plus b.
Hmm.
So a plus b equals 5. And then a plus 2b equals 8. And what can we say about that?
Well, then we know that b is 3.
Okay.
Just subtracting. And then a is 2.
So the integral, actually I'll move it up here, 2 and 3. This integral, what was it, from 0 to 1? Is the same as this integral from 0 to 1. And what is this integral? What's the integral of 2 over x plus 2?
It's 2 ln of x plus 2.
From 0 to 1, and plus, what's this integral?
3 ln x plus 1 from 0 to 1.
Again, from 0 to 1. So our top here is 1, so that's 2 ln of 3 minus 2 ln of 2 plus 3 ln of 2 minus 3 ln of 1. So this simplifies fairly nicely. That's 0.
Mm-hmm.
I get 2 ln 3, and then I get plus ln 2.
Okay.
So I get 2 ln 3 plus ln of 2. And what is that?
Well,
What does that simplify to be?
so the 2 ln 3 is ln of 3 squared, which is ln of 9.
Okay.
So I think it's ln of 18.
And that's a choice. I actually forgot to bring the answer key down. But I want to show you there's another way you can approach this problem. And this is more of a test-taking strategy.
Alright.
So if you're stuck on a problem like this, you can actually just pretend you have area here and approximate it. So at 0, this is 8 over 2. So at 0, this is, again, 8 over 2, which is 4. At 1, it's 13 over 1, 4, 6. So 13, 6. So a little bit more than 2.
Mm-hmm.
So I've got basically the area of a trapezoid, I've got to add those two together. So that's multiply by 1 and then divide by 2. So 24, 6 plus 13, 6. So 37 over 6 divided by 2. Divided by 2, so that, which is very close to 6 over 2, so 3. So the area here is approximately 3. Like this is a nice, like related to ratio of polynomials. It's not going to be quite a straight line, but we know the area is going to be roughly 3. Okay? And that means inside of my ln's, if ln of x equals 3, what is x?
So x is e cubed.
E cubed, okay, which is 2.7 cubed. So we know it's you know, well, 3 cubed is 27, and 2 cubed is 8, and we know it's closer to this, so maybe we're looking for something that's around 20.
Yeah.
Okay. So, divergent.
We know it exists, so no.
Yeah, we know it exists because we know this is always defined between 0 and 1.
That's way too big. That's possible.
Okay.
Then these two are a little too small.
Well, we don't know for sure. This is 13 and a half. So it certainly looks like 18 would be the right answer, and that's definitely too
Because
small.
we know it's going to be closer to 27 than to 8.
Well, yeah, I mean, probably.
Yeah.
Because, I mean, this is a pretty crude approximation. But anyway, that's how you could, if you're just stuck, that's how you could actually at least get it down to 2 and have a sort of educated guess that that's the answer. All right.